Okay, so today we're going to talk about piecewise functions, and these are functions that are actually broken up into pieces. So we're going to look at all the functions we've looked at, and we're going to kind of puzzle them together. So what that means is on the same graph, you're going to have different parts of different functions. So before we get into that, let's look at all the different types of functions we've studied this year. So the first function we studied were lines. Okay, those are straight, they have constant rates of change, all that good stuff. The next one we learned about were parabolas. Okay, these have a vertex. They either open up, they open down, and we learned about domain and range with those, depending on what they look like. We then learned about absolute value functions, which look like that. And then they also have a vertex, those are symmetrical. And then we finally learned about exponential functions that kind of go like that, and different variations of those. So keep that in mind as you're graphing these. Make sure you have your graphing calculator with you because that's really going to help you. So as it says here, a piecewise function is the type of function where the domain, and remember domain is x values. So the domain, the x values are split up into different intervals, and a different type of function is used for each interval. So piecewise functions look like this. They'll have notation, so this function is called f of x, and it'll have two parts to it. So it's usually denoted, it always has a squiggly bracket like that, and inside the squiggly brackets are the functions that they want you to use. So the first one is x squared. And that is the OG function we talked about, or the parent function for a parabola. Okay, so we know that that's going to look like a parabola, but it's only going to look like a parabola from x values of -3 to 2. Okay, and then the next one, it'll look like a line. We know that that's the form of y equals mx plus b, and that's going to look like a line from 2 to 5. Okay, so first what I want you to do is make tables before you graph them. Okay. And if you look, there's a couple things we have to talk about. In the domain, do you see how there is equal to, and then this one is not equal to? Whenever it's equal to, that means that it's defined at that point. So you can fill it in, just like a number line. So if you remember from plotting inequalities, whenever it's whenever it's equal to, we fill in the dot. This means it's undefined at that point, which means you should leave an open dot. Okay, so if it's not equal to, you're leaving the circle open when you plot the point. Okay, so first let's fill out the table. So I'm going to put in x values -3 to 2 in this first table here. So let me zoom out a little bit. So -3, -2, -1, 0, 1, 2. And this will be x squared. So I'm going to go in my calculator and type in y equals x squared. And I'm going to look at my table. And I'm only interested in the points from -3 to 2. So from -3, it's 9. -2 is 4. -1 is 1. 0, 0. 1, 1, 2, 4. Okay? So a place to remind yourself, you're going to want to remind yourself what point to leave open and what point to leave closed. So this is going to be a closed point. This one, though, because it's not equal to, is going to be an open point. Okay, so when you graph it, you're just going to want to leave that open. Okay, so let's graph this line. So I'm just going to graph from these points, -3 to 9, or just from -3 to 2. So -3, 9 is here. I close that point. -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. But remember, you got to keep the point 2, 4 open. Okay, so I know that this is a parabola. Okay, but I'm ending at -3 and ending at 2, so I don't put arrows on those. Okay. All right, now let's do the other piece to the function. The other piece of the function is x plus 2, and that's for the domain where the x value is 2 to 5. So in this table, I'm going to do 2, 3, 4, 5. Okay, So now I'm going to plug in the function x plus 2 in my table. So I'm going to go y equals x plus 2. And you don't have to use your graphing calculator, but it's faster. So at 2, the point is 2, 4, 3, 5, 4, 6, 5, 7. Okay, and for this one, let's look at our thing. So these are both equal to, so this is going to be filled in, and this is also going to be filled in. Okay, so now I'm going to go plot this piece. All right, so 2, 4, so now this one is closed. So 2, 4, that's closed. So now we end up actually filling in that line. 3, 5, 4, 6, 5, 7. And those are closed too. So then I can connect my dots here. But remember, there's no arrows because it ends at 5 there. So you just made your first piecewise function. This piece of the function is a parabola. This piece of the function is a line. So there's 2 pieces, there's 2 functions, and they want you to graph it as kind of like one graph. Okay? So basically, the function, the name of the function will be here, and there will be the function, what they want you to do for the function, and then where to do it on your graph. So it's going to tell you what x values it wants you to use what function. So for this function, it wanted us to use -3 to 2. So I filled in my x values, -3 to 2, and only filled in my y values for those x values. And then for this one, it wanted me to do 2 to 5, so I did 2 to 5 and only filled the y values in for there. Then I plotted. Some things you need to be careful of is if these are equal to or if they're open, that's going to determine if you need to leave the points open or closed. Okay? The reason that these points are open and closed, if they were both closed, sometimes you'll run into when there's discontinuous. If there's 2 points open or 2 points closed like this, that right on top of each other, this wouldn't pass the vertical line test. Okay, so I'll show you some more examples if you're not understanding that just yet. Don't worry about it. We'll practice some more examples. So I'm going to end this video here. If you feel like you want to do one more example with me, go ahead and watch the other video that's on Schoology.